Hello guys, this is Shubham Karwa and I am a student of final year of engineering. I have given assignment to create a small YouTube video describing parallel database architecture, and I have created, and here we go. So introduction. Parallel machines are becoming quite common and affordable. Prices of microprocessors, memory and disks have dropped sharply. Databases are growing increasingly large. Large volumes of transaction data are collected and stored for later analysis. Multimedia objects like images are increasingly stored in databases. As you all are using social medias like WhatsApp, Hike, Instagram, Facebook, etc. These all social medias have large, large number of data. So to store all this data, we need some efficient technology. So large scale parallel database systems increasingly used for storing large volumes of data, processing time consuming decision support queries, providing high throughput for transaction processing. So parallel database architectures. What is parallel database architecture and what it contains? Shared memory, shared disk, shared nothing, hierarchical. Shared memory. Processors share a common memory. In shared disk, processors share a common disk. In shared nothing, processors share neither a common memory nor a common disk. Hierarchical. Hybrid of the above architectures. So we will go through one by one all these. Okay. Let's first go through these four images or diagrams. So in figure A, shared memory is shown. As you can see, there is only single memory box and many processors are there. So we can say that in shared memory, a single memory box is shared by all the processors. In figure B, shared disk. There are many memories, many processors, but disk is single. So like in shared memory, shared disk, in shared disk also a single disk is shared by many processors. So we will go through shared memory and shared disk first. Shared memory and shared disk architectures. Shared memory. All processors share a common main memory and secondary memory. Load balancing is relatively easy to achieve but suffer from memory and bus contention. Load balancing, why is it is easy? Because we use only a single memory, and when we use a single memory, when um, uh, for example a processor P1 modifies some uh, uh, changes in a memory, then it will be seen by all the processors. So shared disk. All processors, each of which has its own local main memory, share the disks. Share memory. Extremely efficient communication between processors. Downside is not scalable beyond 32 or 64 processors. Widely used for lower degrees of parallelism. 4 to 8. Shared disk. IBM's Plex and DEC clusters, now part of Compact or Hewlett Packard. Running relational database, now Oracle Relational Database, were early commercial users. Means examples of shared disk are IBM's Plex and DEC clusters. A downside, bottleneck at interconnection to the disk subsystem. Shared disk systems can scale to a somewhat larger number of processors, but communication between processors is slower. So now shared nothing. I will go back to that slide. Share. As you can see in figure C, shared nothing is shown. In this shared nothing, each processor is having its own memory, its own disk. So uh, each processor will not share its own memory and its disk to other processor. So it is called shared nothing. Each processor has its own local main memory and disks. Load balancing becomes difficult. As you can see in figure 1.13, a shared nothing architecture. A CPU 1 has its own disk and its own memory. CPU 2 has its own disk and its own memory. So shared nothing. Examples of shared nothing are Teradata, Tandem, Oracle, Encube. Data access from local disk and local memory accesses do not pass through interconnection network, thereby minimizing the interference of resource sharing. Shared nothing multiprocessors can be scaled up to thousands of processors without interference. Main drawback. What is the main drawback of shared nothing? Cost of communication and non-local disk access. Sending data involves software interaction at both ends. Cost of communication is very high, and non-local disk access means we shared nothing in we shared nothing in shared nothing architecture. That is, if a processor P1 modifies some changes in memory M1, then it will not be seen by other processors. Hierarchical, as and combines characteristics of shared memory, shared disk, and shared nothing architecture. We will go through that figure also. In figure D, hierarchical is shown. As you can see, there is the architecture in which it can be shared memory, it can be shared disk, and it can be shared nothing. So in this way, I have tried my level best, friends, to describe what is parallel database architectures. So thank you.